Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. Among our content, you'll find videos describing topics in mathematics from algebra through calculus and more advanced topics. If that's something you're looking for, please consider subscribing and checking out some of our other videos. Let's get into the current video. What I want to take a look at is transformations of piecewise functions, in particular horizontal shifts. That means if I take a graph of a piecewise function, if I do a horizontal shift, first of all, what does the graph look like? More importantly, what does the function expression look like if I did a shift to the left or to the right? Let's take a look at an example. Let's take a look at a piecewise function that has two expressions. Let's say I've got 2x if x is less than 0, and I've got x plus 1 if x is greater than or equal to 0. Let's do a couple of things with this. First and foremost, let's sketch the graph of what that would look like. Okay. So again, x-axis, y-axis. The two expressions that I have to put together here is the graph 2x and x plus 1, and these inequalities here tell me for which x values that graph applies. In particular, we use the graph of y equals 2x when x is negative, and that would give me the following. 2x would have again, I'm not going to be super accurate here, just to kind of get a ballpark. Slope of 2 excluding the origin. See if I can get rid of that origin there. So that would be the graph, say y equals 2x, and then x plus 1, y-intercept at positive 1, and then a slope of 1. And I'll just make it less steep than this one. Okay? And the graph would look like this. This would be the graph of the function f of x. What I want to do is let's take that and let's shift it different ways. Let's take a look at shifting that graph. Let's say shift f of x, let's say 2 units to the left. What that means is I want to take the sketch of the graph and shift the graph. Okay. If I take this portion that goes to the origin and I shift it 2 units to the left, that means it's going to go over to here. And if I take this part of the piecewise function graph that has a y-intercept of positive 1 and I shift it 2 units to the left, then it would be here. And look like this. Okay. What I want to know is what is the function expression for this shifted graph? Well, let's see. Since this is not the same function, let's call it a different name. So let's call this one g of x. And of course it has two components. I've got this part right here that has a slope of 2, this part right here that has a slope of 1. Well, what are the expressions for that? Well, for this line right here, again, this has so slope is equal to 2. And let's see, I know that if I were to continue this line, it would pass through this point. And again, it doesn't matter if it does or not, because I'm trying to find the equation of this line segment, which would be the same as the entire line segment. And of course, this point here would be back to up 0. Let's find the equation of that line then. Let's do that down here. Okay, so remember that the point slope form is y minus y naught is equal to m times x minus x naught. Okay, and I've got the slope and I've got a point. Well, that means I'd have y minus 0 is 2 times x minus negative 2, which is y is equal to 2, remember this in here, negative is positive, that'd be x plus 2. So 2 times x would be 2x, and then 2 times positive 2 would be plus 4, 2x plus 4. Therefore, the graph would be 2x plus 4 when x is less than what? Well, it's up to, remember, this shifted 2 units to the left, therefore this graph is appropriate when x is less than -2. Okay. Now let's find the equation of this line on top. Well, again, the slope is same thing. The slope is 1, right? If I shift it to the left or to the right, if I just do a horizontal shift, I'm not changing the slope. And it also passes through the point. Well, what would this point be right here? Back to up 1. Therefore, that's back to up 1. Okay, now let's find the equation of that line. Again, using point slope form, I have y minus the y value, which is 1, is equal to the slope times x minus, and barely squeeze that in there. Hopefully that shows up on screen. And then that gives me y minus 1 is, well, 1 times anything is anything. And inside the parentheses, I'd have x minus 2, which would be x plus 2. Therefore, that gives me y equals x plus 3. Right? And so the equation down here would be x plus 3. And when do I use that expression? Well, if I look at the graph here, that x plus 3 is used from -2 to the right. That means that x would be greater than or equal to -2. Okay. In what follows, I'm going to show you a much more efficient and straightforward way to find those components. In this particular case, right, I've got 2x and x plus 1. Those are pretty simple expressions. If I start throwing in like quadratics and radicals and all sorts of, expressions that you've used, this could get pretty complicated to come up with the exact expression here for the shifted parts. But what I'm going to show you is going to be pretty straightforward. So let me leave that up there, and let's see. What do I want to erase here? Okay, I'm going to erase just this graph. Just for the moment, I'd like to leave everything else up there just for reference. So let me go ahead and section off this part of the screen. Okay. Now, remember that if I shift a function 2 units to the left, the general expression for that is f of x. Remember, if it's a horizontal shift, it applies, the transformation expression applies to the input, and see if you can think about which way is it. Is it plus or is it minus? And now I'm going to shift it 2 units. So I've got a 2 here. Okay. Well, if I go to the left, what I do is I put a plus here. So x plus 2 is a horizontal shift to the left. Now, remember that when we do a horizontal shift to the left or to the right, or whatever the case may be, I replace, in the function expression, I replace every occurrence of x with x plus 2. Well, let's go back to this function that I had, the original function, and let's do that. So 2, x is going to get replaced with x plus 2. And the second expression, which is x plus 1, I'm going to replace x with, once again, x plus 2 plus 1. The other part of the piecewise function consists of the inequalities. Well, remember that if I'm shifting the function, like over here in green, right, we shifted the function to the left, we also shifted where the function expressions were used. Originally, we had x less than 0, where over here we have x is less than -2. And we can visually see that with the expression. Well, how do I incorporate plugging this in to the original piecewise function? The idea is every single occurrence of x, whether it's the function expression or the inequalities, gets replaced with x plus 2. Therefore, x plus 2 is going to go both in the first inequality, so that'd be x plus 2 less than 0, and in the second inequality, so x plus 2 is greater than or equal to 0. Now let's simplify this. If I take 2 and distribute it through, I would get 2x plus 4. If I subtract 2, I get x is less than negative 2. In the second expression, I can just drop the parentheses and combine like terms, and I get x plus 3. And then if I subtract 2, I get when x is greater than or equal to negative 2. Now let's compare this expression over here that I wrote as the function g of x and the function that I did over here that I wrote as f of x plus 2. Of course they match. The one that we did through g of x, that's how we just found visually and then using some simple algebra. And then over here is how I found by just plugging it in, knowing the function expression for a horizontal transformation. Okay. Let me summarize this. Let me clean up my board, and then I'll summarize it and show you the general procedure, and then we'll take a look at another example. Here's the general idea. Let's say I have a function that looks like this. F of x is equal to, okay, let's say the component functions I'm just going to write generically as g of x and h of x. And let's say the function restrictions or the domain restrictions would be, say, x is less than a, and then x is greater than or equal to a. Now, first of all, let me talk about that generic function first and foremost. I could have any number of finite number of pieces here. I could have g of x, h of x, k of x, l of x, m of x. I could have any finite number of expressions there. And these inequalities, I mean, this could be x is less than or equal to a, x bigger than a. This could be x equal to a, x not equal to a. So there's all sorts of variations there. I'm just going to use this as my general expression. And the procedure is going to work the same way no matter how many pieces I have and no matter how the inequalities are set up. Okay. If I want to do a shift left by, let's say, c units. C, of course, is a positive number, so I'm not going to shift left -2 units, right? I'm going to say shift left by c units, and again, I suppose I should say c is positive just to make it explicit. What I'm going to do is the function expression is going to be f of x. Remember in the previous example, shift to the left was plus c is equal to. Now, the way this works, again, just like the previous example, is every single occurrence of x within the piecewise expression, whether it is in the function expressions themselves or with the inequality domain restriction information, everything gets replaced. Every occurrence of x gets replaced with x plus 2. That means I would have g of x plus c when x plus c is less than a, and h of x plus c when x plus c is greater than or equal to a. Now in practice, what we would do is we would subtract c to the other side, so x would be less than a minus c, so on and so forth. But again, this is the function expression. I simply replace x with x plus c. Now if I want to do a shift to the right, by c units, again, we're assuming c is a positive number. Okay, a shift to the right is x minus c. And similarly to the expression up above, for a shift to the left, if I do a shift to the right, I simply replace every single occurrence of x with x minus c. Let's take a look at a specific example. Let's do one with 3 expressions. Let's say I have x minus 4 if x is less than 1. I've got 5 when x is equal to 1, and x squared minus 4x when x is bigger than 1. Okay? Find the function expression for a horizontal shift 3 units to the right. Okay, so find the function expression for a horizontal shift 3 units to the right. Okay, so solution. If I look at my little cheat sheet over here, I see that shift to the right by c units, where again c is positive. I replace the input variable with x minus c. In this case, it will be replaced with x minus 3. And I get f of x minus 3 is equal to, okay, every single occurrence of x gets replaced with x minus 3. That means that in the first expression, x minus 4, I would have x minus 3 minus 4 when x minus 3 is less than 1. Second expression, there is no x, therefore it stays as is, meaning I have 5 when x minus 3 is equal to 1. In other words, when x is 4. And finally, I have x minus 3 squared minus 4 times x minus 3 when x minus 3 is bigger than 1. Okay. Now, it takes a minute to erase the whiteboard, so what I'm just going to do is kind of walk you through this. You're simply going to combine like terms here. That'd be x minus 7 when x is less than 4. 5 when x equals 4. And then here, you could FOIL this out. You could multiply it out depending on what your goal is, but I'll just leave it as is, and then when x is bigger than 4. Okay. That's the general procedure for how to do a shift, a horizontal shift of a piecewise function. Thank you for watching, and consider subscribing.